This is what's meant to be a pretty simple, straightforward magnetic circuits question that relates to transformers. Transformers often have fiberboard in them to break up that magnetic field a little bit, and that reduces eddy currents. And that fiberboard is not magnetic. So it wants to, stop the magnetism basically from going too high. So in this question, it's just illustrate mathematically why the relative permeability of fiberboard in a transformer core is that of unity, or 1. So if I were to illustrate this, I would say the relative permeability is simply the ratio of the permeability of the material over the permeability of free space, by definition, where the permeability of free space is equal to 4 pi times 10 to the negative 7 by definition. And we know that. We can look that up. There is not a lot of permeability. I mean, there's free space is not very permeable. It does not permit the magnetic flux lines to develop, and it is not permeable to the extent of times 10 to the negative 7. So it's very not permeable. Weber per amp. I like carrying the turns in there, meter. So that's the permeability of free space. Well, the permeability of fiberboard is also not very permeable at all. It is so not permeable that it is equivalent to free space. So it is also 4 pi times 10 to the negative 7 Weber per amp turn meters. So therefore, the relative permeability would just be 4 pi over the 4 pi times 10 to the negative 7, of course. Same units, but I feel the need to put them all in. Which means we can cross out these units because we want relative permeability to be unitless. It's just a ratio. We have the same number on the top, same number of the bottom. And if you divide by itself, you have 1. Therefore, the relative permeability of fiberboard is equal to 1. And that's all there is to that question.